Welcome to Electro CWP. If you're an electrical engineer, or you're aspiring to become one, then you know that the job can be both rewarding and challenging. But, as with any profession, there are certain mistakes that can be costly, time-consuming, and even dangerous. In today's video, I'm going to walk you through 20 common mistakes that every electrical engineer should avoid. Whether you're just starting out in the field or you've been working in electrical engineering for years, these mistakes are ones you need to be aware of to ensure your projects are safe, efficient, and up to standard. Skipping proper planning means starting a project without thoroughly assessing the requirements, electrical load, safety considerations, or designing a clear system layout. It can be tempting to jump straight into installation or design, especially when dealing with urgent deadlines or pressure, but this leads to mistakes that can compound as the project progresses. Why is this a mistake? Inaccurate load distribution. Without detailed planning, an engineer may overlook or miscalculate the total electrical load the system must handle, leading to overloaded circuits, flickering lights, or even fire hazards. For example, a restaurant might have an underspecified circuit that doesn't account for the total power usage of kitchen equipment, leading to trip breakers or overheating wires. Code violations. Electrical codes e.g., NEC or IEC standards are put in place to protect users and equipment. Skipping planning may lead to code violations, which could result in fines, delays, or even insurance problems if something goes wrong. Key elements of proper planning. Load analysis. Calculate the total electrical load for each area, factoring in future expansion. System design. Develop clear wiring layouts, breaker sizes, and device specifications. Compliance. Check the design against local electrical codes and safety standards. Materials and resources. Make sure the right materials and tools are chosen and available. Real-life example. If an engineer plans to install an electrical system for a multi-story office building without considering the growing number of computers, air conditioners, and other power-hungry devices, they could inadvertently overload circuits, causing constant breaker trips and eventually leading to a fire. What is circuit sizing? Circuit sizing refers to selecting the appropriate wire gauge, breaker ratings, and overall capacity for each circuit based on the expected load. Incorrect sizing, either over or undersized, can lead to inefficiency, overheating, or even catastrophic failures. Why is this a mistake? Undersized wiring. If a wire is too small for the amount of current flowing through it, the wire will overheat, potentially causing melting, fires, or damage to appliances. For example, using a 14-gauge wire for a 20-amp circuit which should have a 12-gauge wire may result in wire overheating and possible fire.
If you find this useful, drop a comment. Failing to use the correct protection devices. Protection devices like circuit breakers, fuses, or C-DIS residual current devices, and surge protectors are designed to protect both the wiring and connected devices from overloads, short circuits, or ground faults. Why is this a mistake? Overloading without circuit protection and overload could lead to wires overheating or catching fire. For example, a faulty appliance plugged into an unprotected circuit might draw more current than the circuit can handle, leading to an electrical fire. Electric shocks. Devices like our C-DIS or GFC are designed to prevent fatal electric shocks in the case of ground faults. Failure to install these devices in areas such as bathrooms, kitchens, or outdoors increases the risk of electrocution. How to avoid it? Always include protection. Include overcurrent protection devices, for example, circuit breakers or fuses on all circuits. Consider ground fault protection. Ensure the use of our C-DIS or GFC is for certain areas where applicable to prevent electric shock. Real-life example. If an office space fails to include surge protection devices on circuits, a lightning strike or power surge could cause extensive damage to computers, servers, and other sensitive equipment. Installing surge protectors prevents these issues, protecting expensive assets. Ignoring proper grounding and bonding. Grounding is the process of connecting the electrical system to the earth to provide a path of least resistance for fault currents. This prevents electrocution and electrical fires by directing unwanted currents safely to the ground. Bonding refers to the process of electrically connecting metal parts like conduit, electrical boxes, and frames to ensure that all conductive materials are at the same electrical potential, reducing the risk of electric shock. Why is this a mistake? electrical shocks. If the system is not properly grounded or bonded, metal parts like water pipes or electrical enclosures could become live during a fault, causing potentially fatal electric shocks. Electrical fires without grounding, a faulty device could result in sparking or overheating, leading to fire hazards. In the absence of grounding, fault currents might not dissipate correctly, causing localized heating in the system. How to avoid it? Install grounding systems correctly. Ensure grounding rods, conductors, and electrodes are installed according to code and connected to the electrical panel. Proper bonding. Bond all metal parts of the system to prevent differences in potential that could lead to electrical shock. Real-life example. In an industrial setting, if the metal casing of a machine is not properly grounded and a fault occurs, it could lead to the casing becoming energized, putting workers at risk of a fatal shock. Proper grounding would ensure the fault current flows safely to the earth, triggering the breaker and preventing any eye. If you enjoyed this video, please like and subscribe for more. How to avoid it? Plan your cable routes carefully. Use cable trays or conduits to protect the cables from external damage and ensure they are not placed near heat sources or sharp edges. Incorrectly labeling circuits. Failing to properly label circuits can cause confusion during maintenance or future upgrades, leading to accidents. How to avoid it? Label all circuits clearly and update labels when changes are made. Use a circuit directory to track the circuits and their functions. Ignoring electrical drawings. Some engineers might neglect the importance of electrical drawings, especially during installation or commissioning. Not having proper diagrams can lead to incorrect wiring or missed connections. How to avoid it? Always create and refer to electrical drawings before beginning work. These are essential for accurate installations and troubleshooting. Inadequate testing before commissioning. Before commissioning a system, engineers sometimes fail to test the system thoroughly. This can lead to faults that were not detected before the system goes live. How to avoid it? Perform comprehensive testing on the system, including continuity tests, insulation resistance tests, and grounding tests before commissioning. Not considering future expansion, electrical systems are often designed with only the current needs in mind, without considering potential future expansions. This can result in the need for costly upgrades down the line. How to avoid it? Design electrical systems with future expansion in mind. Include extra capacity in your circuit designs and leave room for additional circuits or equipment. Failing to keep up with industry trends, electrical engineering is an evolving field, and failing to keep up with new technologies, standards, and methodologies can leave you behind. How to avoid it? Stay updated on industry trends and standards. Participate in training programs, read journals, and attend seminars to keep your skills current. Not using the right tools. Using improper or poor quality tools can lead to mistakes, delays, and even damage to equipment. Not using the right tools. Using improper or poor quality tools can lead to mistakes, delays, and even damage to equipment. How to avoid it? Always use the correct tools for the job. Invest in high-quality tools and ensure that they are well maintained. 16. Overestimating personal abilities. Electrical engineers sometimes overestimate their abilities, leading to mistakes or dangerous situations due to insufficient experience or knowledge. How to avoid it? Understand your limits. If you're not familiar with a particular system or process, don't hesitate to consult with more experienced colleagues or seek help from specialists. We appreciate your support. Like and share our video.